Is the video presentation of the medical concept embedding with variable temporal scopes for patient similarity paper ID 29, group ID 191. I'm the only group member. So what's the paper about? It's basically measure similarity and evaluation across patients utilizing EHR. This framework is a representation learning method and utilizes the distance metrics over the lane patient representation vectors. Due to the nature characteristic of electronic healthcare data, traditional machine learning models are unable to fully incorporate patients' features due to the temporal characteristics of the patient's events. The proposed framework is built into 4 blocks. Patients' medical concepts are built and mapped to the knowledge-based database. Semantic relationships are built following the natural language search methodology. This is taken as sequence of medical codes, which is regarded as text. Patients' feature measures representation is built and consequently fed into SME, CNN, and SPP to perform similarity across patients. What's the model architecture? Basically, patient profiles are built and sorted by their timestamps and mapped into the medical codes, ICD, NTC, OPT. Word2Vec is used to construct the medical code embeddings using variable temporal scopes. Such medical code embedding vectors are stacked to build patients' matrices and use them as input for the SME, CNN, and SPP to perform patient similarity. What's the model contribution? It's definitely an extension of the natural text methodology through the skip-gram model. Such extension is carried out in combination of 2 methodologies, SAMI, CNN, and SPP. In this sense, EHR are mined and converted into fixed-length vectors so that patient's information is learned and meaningful semantic relationships are extracted to find patients alike. So what are my reproduction attempts? I follow exactly the same data preprocessing in the same fashion and order as the authors did. Remove patients with missing data on admission date and discharge date. I kept patients with at least 30 medical codes. Patients with discharge date after 2200 were removed, and patients with missing data on diagnosis were also removed. And there were 9 cohorts that basically were utilized for disease cohort classification. I didn't exactly achieve the same results as the authors did. I computed all the metrics that they did. In this case, for example, the baseline methods outperform my results. PCA and HDM, human distance metric, outperform my HRR metric. When it comes to the incidence rate difference for mortality, also the baseline methods outperform my results, and in this case, PCA performed the best. When it comes to disease classification, PCA outperformed my AUC results when it comes to disease cohort classification, and the same reason was for mortality. So these are basically the potential reasons why I didn't mirror exactly the same results as the authors did. I used the version 1.4 of the MIMIC3 clinical dataset. The authors didn't state what version of the MIMIC3 they used. After data preprocessing, my number of records were over 23,000, whereas the authors were over 18,000. There were 2 important implications that might definitely affect the difference in results. The way the authors preprocessed patient records to assign cohorts, I didn't really have any guidance as how they did it, and the way authors ranked patient events in increasing order according to their timestamps. This is huge for me in regards how I came up with my results. The MIMIC3 doesn't provide any code level timestamp. I can only rank the codes by their timestamps across admissions, but not within a single admission. Most important claim from the paper on how the authors proposed framework incorporates temporal information to perform PSC. So I don't know whether they have any additional data, or I didn't have any guidance, for example, as exactly what was the methodology they used, since MIMIC3 doesn't provide any code level timestamp. Thank you for watching.